Hello guys and welcome to my channel. In this video, we will be taking a look at the AP Statistics free response questions from 2022. I will go over each questions in separate videos. This is question number 1. And for the first question, what we have here is that we have a scatter plot of the explanatory variable and the response variable as indicated right here. A biologist gathered the data on length in millimeters and the mass for the 11 bullfrogs. The data are shown in plot 1. So based on the scatter plot, describe the relationship. When they're asking you to describe the relationship between the x and y on a scatter plot, it's usually the acronyms I say it's DOFS or I pronounce it as DOFS. So those 4 letters stands for direction, outliers, form, and strength. And when you mention all these 4 components in describing the relationship in a scatter plot, you will get full credit for it, no matter how you do this. So for the relationship that we see, I mean, clearly we can see that this is going to be a positive linear direction. So you can first start off with by saying that the relationship between the mass and length of these 11 bullfrogs can be described as linear, positive, and we took care of the direction and the form. Now let's first talk about strength. The strength for this, you need to see a bunch of examples to kind of determine this and get better at it as you go. However, this is not going to be categorized as strong. If it was strong, then the dots would be much more closely compact and they will actually resemble an actual line. And for this, you can see how, the distance amongst the dots are kind of like fairly somewhat distant from one another. So we're going to say it's moderately strong. So linear, positive, and moderately strong. So we have taken care of the strength form as well. Now, you want to describe the outliers in some way, some form of fashion. So if you take a look at the dot that's actually furthest away from the linear equation or the linear line that you can kind of picture in the scatter plot, you can say that that's an outlier. So there can be a potential outlier with length of, I would say, about 160 millimeters. So it's about 160 and somewhat about 350. And with mass about 350 grams. So outliers usually, how do you determine whether this is going to be an outlier? I mean, how can this not be an outlier? Generally speaking, you don't want to mention too many of the outliers. Like you want to mention maybe just really obvious one that's like really far away from the line as much as possible. And so mentioning maybe 1, maximum 2 should give you a full credit for this. So that should be for part A of number 1. Now for number 2, identify, interpret the slope. Identifying the slope should be fairly simple. Here we have the equation with the y-intercept of -546 and the slope multiplied by length. It's always the number that's in front of the explanatory variable. So the slope is 6.086. Now, even when you are talking about algebra 1, slope always means the rise over run, right? And so if we were to say that the slope is 6.086, it means that the mass has increased by this much, where the length is just a unit of 1. So as the bullfrogs increase in length by 1 millimeter, so by 1 millimeter going to the right in this direction, comma, the mass will increase by about 6.086 grams. So you're mentioning that number in that context, indicating that that's the slope, and that's what it means. As the length increases by 1, your mass will increase by about that much. It's always about that rise over run here. In AP stats, they like to ask you this type of question. R squared is equal to 0.819. We know that R is the correlation coefficient. And it basically measures how close in proximity are the dots with the line. The higher the R value, that is somewhere between -1 to 1. 1 and -1 being really, really strong in positive and negative direction, 0 being like absolutely zero relationship. So if I have an R squared, the way that you format this is that there's always a template for this. About 81.9%. So the first things first, we convert that into a percentage. So that's 81.9%. And then we say of the variation of the response variable, which we say mass, of mass in grams of the bullfrogs can be explained by the linear regression model or linear regression line, we say. Least squares regression line, I'm sorry. I abbreviate it as LSRL. It can be explained by the LSRL with the explanatory variable as the length in millimeters. So what in the world does this mean? So first, we have our response variable, the 81.9%. That's what R squared clear. That's what this is all about. Of the variation of how, the line is not going to be 100% perfect all the time. You can see how it differs by quite a bit. About 81.9% of the variation, however, can be explained as best as it could with the linear equation that's provided for us above. With the explanatory variable as length, we need to clearly state that. So the response and the explanatory variable is clearly stated, and also mentioning of the LSRL, least squares regression line. Okay, so we have plot 2. Consider the residuals. Okay, so what is a residual? Residual is actual minus the predicted. It's always how far are the dots from the line itself. So based on the plots, approximately what is the length and mass of the bullfrog with the largest absolute value residual? This is kind of talking about the dot that is actually furthest away from the line. And as you guys can see, that outlier that we mentioned, that's pretty much the one with the largest absolute value of residual. So if we were to take that dot and say, I would say that's probably about a length of 160, I don't know, 163-ish maybe. And then it's a little higher than 350. So I'll just kind of give it a number and say 355 approximately. Use the word approximately about to your to your like however that you would like to use it. The more that you use them, it just sounds better overall in the context of your answer. Based on the plot. And so what is the length and mass? With the largest absolute value. So here's the predicted that is actually on the line. So we want to subtract always the y value. So the residual will be actual minus the predicted, where the mass of the bullfrog is about 355 grams, whereas the predicted line yields about, I would say, I mean, that's kind of close to being, I would say, give or take about 440 grams. So the residual will be about, what would that be, 85? There's no like clear answer. I think the answer key would say anywhere between these two numbers it will do. So when you clearly state the predicted and the actual and you subtract those two, you should be fine. Does the least squares regression line overestimate or underestimate? I think that should be pretty clear. It's gonna be an overestimate. First, you want to state that. That will give you 1 point for this question. Why is it an overestimate? Because obviously the line is higher than the dot. Overestimate because the predicted mass on the least squares regression line is greater than the actual mass of the bullfrog. Generally, you want to put more context in terms of the sentences. I just summarized it in like one sentence kind of answer. As long as you state all the necessary requirements, but if you want to get those extra brownie points, you want to kind of state, maybe at least give a one more sentence. 2 sentences is ideal for these types of questions. But this clearly has all the essential ideas behind it. So that should summarize for number 1 for the AP stats, and I will upload the other questions in other videos. How do you add? Can you add music to this? Hello guys, welcome to my channel. Oh, let me take a little break, Mose. Where do you want to go? Kobe Bryant. Black. Oh shit. Yeah, I forgot.